This video clip will introduce you to Boolean variables and operations with Boolean variables as used in conditions. Welcome back and ready for another data type. You're not done yet. What's the next data type? That is Boolean. It's often misinterpreted as it's just a condition. It is used in conditions because a Boolean variable is something that carries the value true or false. So that's like a condition. If this is true, do this. If it's not, do that. But it is a variable. That means we can store it, we can build operations upon it, and of course, we can use it in conditions. The question is always, how does a programming language represent the values true or false? So let's start. What is true? True, there's the keyword true. Careful, uppercase T. But any non-zero variable value is also true. So 3 is true. Pi is true. Any non-empty list is true. That means our lists 1, 2, 3, 4 is true. You can say if list 1, 2, 3, 4, then do something. Yeah, that's true. Similar thing, every non-empty tuple, any non-empty dictionary, so a dictionary needs at least a key, any non-empty string, if Tuesday is true. And we will see that later, any reference to an object, if that object exists, is true. Contrary, what is false? Pretty much the opposite. False is the keyword false. A 0 integer or a 0 floating point value is false. An empty list, so just bracket open, close, nothing in the list, but just the list, empty is false. So if you think of a condition, if this list is empty, you just say if list. Because if it's empty, it's false. If or it's not empty, it's true. So you may have to do if not list to get the condition if this list is empty. Similar, an empty tuple, an empty dictionary, an empty string. So that's single quote, or double quote, nothing in between the quotes. And an empty pointer. Something, again, we haven't talked about it. If you create an object that isn't there, then it's like a variable that doesn't point to any data. So let's play a little bit with this. So the easiest thing is, of course, to just assign them. I have two variables, u and v. U is true, v is false. So we assign it like a numeric value. And we can combine those things. So we can say u and v. So let's start before we press anything. U is true, v is false. U and v, and the operator and is a Boolean operator that takes the variables and says both need to be true. So let's execute it. U and v, it's false because v was false. U or v says one of them, at least one of them needs to be true. Hey, yeah, u is true. And the nice thing is, as soon as this is or, it doesn't matter what v is. If u is true, we are good. But we can play this and say, what do we think is the answer of u and 1 or v? So u is true. 1 is true because 1 is not 0. Any non-zero value is true. So this says true and true. Yeah, both are true. The parenthesis evaluates to true and says, or, hey, true or something, it's fine. And the interesting part is the answer is 1. 1 is true, but the value, how it does it, it said true and 1, and it assigns the value, the last value of what has been evaluated. The last thing it looked at now was 1. It came, the result of this is 1, which again is interpreted as true in a condition. And then says or, since it knows true or whatever, it doesn't even look at v anymore. If we look at this next one, is a bit different. U or v and 1. That's true and not 1. How did that work? It says true or false, and it's already there. True or is done. It never looked at v, it never looked at 1. And that brings us also to the other logic. How are things evaluated? They start from the left and work their way to the right as far as necessary to give the answer whether or not the result is true or false in a Boolean sense. So you can assign this to a variable. Let's bring this a step further and say u and empty string. Empty string is false, u is true. This requires that both are true. So it says, no, that's false. The last thing it needs to look at for this is the empty string, and that is exactly the answer to this. So how do we work with those? Of course, we use them mostly in conditions. So let's start with conditions here. I do a simple sign. I assign a variable, and I say if a is greater than 3, print. There's nothing else doing. You see the indentation, that means that's going in that block. So as I execute this, yes, a is greater than 3, and it prints it's greater than 3. Just to demonstrate, if I change that to 30, it prints nothing. Yeah. So why? Because 5.5 is not greater than. I can go back in there. But now let's make this thing a little bit interesting. And that is where programming styles, where I hope we see a new skill in you are developing. A Boolean variable, any condition is a value. A value can be assigned to a variable. And I can name the variables such that they make sense. So a Boolean variable, I like to name them is something, has something, greater than something. So let's look at this. I define here a dictionary that's describing me. Yeah, I have a name. The name is a string, Peter. I have an age, and yeah, getting up there. Height, for everybody who thinks metric, 1.98 m, just failed to get the 2 meter mark, otherwise 6.5 feet. And the weight is in pounds. No, I do not weigh 215 kilograms for our international guests. That would scare the heck out of me. So now we do a little bit of operations on me. And I do here, I assign value to a variable is tall. How do I define if somebody is tall? And I say if the height, and I look at the dictionary, there's a keyword height, is greater than 6 feet. Yeah, if you're greater than 1.80 m, they're gonna call you tall. We're gonna see is heavy. Okay, you know what? If a guy is heavier than 180 pounds, I call him heavy. Then there's BMI for everybody who ever went to a doctor and they try and figure out if you need to eat a bit more or a little bit less. There is that meaningless indicator of body mass index BMI. If you look up a medical journal, it's a funny little thing that says weight in kilograms divided by height in meters squared. And if you do English units, you have, of course, always these pesky little conversion numbers everywhere. It's just an equation. We compute that, and now the doctors say, we call you overweight if your body mass index is somewhere between 25 and 30. So I make a condition, if your body mass index is greater than 25 or less or equal, or and. So and is necessary to say you are in a range, because if you are greater than 30, they call you obese. Yeah, so this is what? It's just computation, but a lot of those computations, first, second, fourth, and fifth, are actually Boolean operations, where we look at this, and then we do another one and say, hey, is tall and healthy? We call a guy is tall and healthy if that guy is tall and not overweight or obese. So the parentheses, check this. If you're either overweight or obese, then there's a problem. Not turns this into the opposite. So it means we are not overweight and we are not obese, but we are tall. And then I just put here the condition, if is tall and healthy. I don't need to write is equal to true or something. It's a condition. If is tall and healthy, print, oh, that guy is tall and healthy. Let's try that. Hey, Peter is tall and healthy, and my wife thinks I'm handsome too. So, where are the sloppy ones? The things that I say, how do I know you did not understand that chapter? If you write conditions that look like this, like A is true, and I say, if A equals true, print true. Hey, what is this? That prints true. Let me show you how we could do this thing much easier. There are clean ways. If I take this, if A, because A is Boolean, is a condition. And if I say, you know what, I want to know whatever A is, I could just leave the if condition, say print A. Yeah, that would also do it. Either way, works fine. But the main thing is, don't check if something's equal to true or false. That's how that works, if it's empty or not empty. Much easier to read if I have A. The other thing is what I see the time people doing. We check if A equals 1, and people say if A equals 1 equals true. Of course it works, but it is hard to read. It's a mess. So I would not recommend doing this, and instead make this a nice clean way, and that's where it looks much more normal. Yeah, then we can work that way. Yeah, so keep this in mind. Do things nice, do things neat and clean.